Good afternoon. Can you hear me okay? My name is Ian Munnick. I'm a manufacturer's rep with MSA Components and a member of the SPE Thermoforming Division Board. I have the honor of being the chairman of the Research and Development Committee. So our thoughts on the R&D Committee, our job is to find the technologies, the processes, the material improvements which will help the processor's life be easier, be able to compete with other competing industries. So I asked Darrell to show you his company's new technologies in tool development, which we think could really be a huge advantage for thermoformers across the industry. So with that, Darrell.
Thanks, Ian. Good afternoon, everybody. As Ian said, my name is Darrell Stafford with Catalysis Additive Tooling. And this isn't intended to be a sales presentation, so I just have one slide about the company so you can kind of understand what our background is. So Rick and I started this in 2016, so we're about 5 years old. We have a lot of experience at Honda in the engineering side, myself, and additive manufacturing, and he's from the purchasing side. So really, we're talking about 3D printed tooling, how we reduce time and costs, and still give good quality product. And the unique thing about our company is we're the complete solution provider, which means we design the tool, manufacture the tool, tool-based manufacturing, and also tool quality verification. So it's the one-stop shop. There's a lot of companies that will 3D print, all kinds of companies, but we're the one-stop shop for tooling. So today we'll just talk a little bit about traditional thermoforming methods. You guys all know that. We'll talk about 3D printing technologies, what's available today, the benefits of 3D printed tooling, where does it fit, because it's not, it's just a tool in your toolbox. It's not going to replace RAN or metal tools, and an open discussion. So just kind of a show of hands, who's used 3D printing? Not for tooling, but who's used, it's common. They have it in high schools. It's very common. It's been around since 1985. You can buy FDM printers for like $300, $500. Everybody should have one as part of the product development process. Who's used this for tooling? Quite a few. Well, that's pretty good. That's pretty good. I hope it was our tooling, but we can talk about that. So one question on that. Anybody used metal 3D printing for tooling? Mostly the plastic and things like that? Okay. So this is, when I talk about additive manufacturing, and maybe this term gets confused with this. We're talking about 3D printed tooling. It's really under this umbrella of additive manufacturing. It's like thermoforming. You get into twin sheet, pressure forming. We're talking about 3D printed tooling. There's a lot of other things you do with 3D printing that kind of make up additive manufacturing. And so, of course, additive is adding. It's not subtractive the way we've done it for years and years. So how do we make tooling today? You guys know this better than I do. Ren wood, so you've got tooling board, things like that. You can go to Home Depot and get some nice wood and glue it together. You can form parts off of it. That's been around forever. Metal tools, so of course it's a water-cooled. Aluminum tools, it could be cast or billet. Metaphor, if you guys have used that, Metaphor tooling, the porous aluminum. And then, of course, ceramic tools and things like that. But there's probably more, but you guys are very familiar with that. When we talk about 3D printed toolings, the different technologies, FDM, SLA, you probably use these types of things for tooling, which is what this is, layer by layer, building up. It's kind of like the weed eater wire. You're familiar with that? SLA is a resin with a laser, and you build that layer by layer, a lot higher resolution. Composite ceramic, metal, there's a metal one in here somewhere. And then, of course, binder jet is what we primarily use, not just binder jet, but that's what we primarily use. This is kind of an eye chart, but these are all the 3D printing technologies. And as a company, we're very agnostic to 3D printing technology. We're diverse, so we'll use whatever technology makes sense for that tool, depending on size, quantity, and quality. So we've used SLA, we've used FDM, material jetting, binder jetting, which is our primary tooling, and metal. We've used all of those, and we've combined those in tools, and I'll show you. So key points of 3D printing, there's advantages and disadvantages, of course. It's not going to fix all of your thermoforming solutions, but it's just that each one has a different advantage and disadvantage. We apply the correct technology for the correct application. So if it's a very small part, maybe very high surface quality is required, we may do an SLA print or an HP print. If it's a very large tool, we may use a binder jet. So it's always case by case. And I was at Rapid. I don't know if you guys, anybody's been to Rapid or FabTech, but it's all the 3D printing technology. So we always go there to understand what's the latest and greatest technology so we can be on the front edge of that when we're developing our tooling. So this is an example. This is an actual refrigerator door. This black is our tooling. This little white beige are actually FDM 3D printed parts for the undercut areas. There's actually 40 of these all around the tool. So it just shows how we're technology diverse with a binder jet tool, and then the undercut hand loads, or a little FDM, Ultem, if you're familiar, probably people have used Ultem, very good material. So that's just combining those two. This is another tool. Again, this is our binder jet fully porous tool. This is the HP MJF technology, very high resolution, like 25 micron layer res. So we needed that kind of definition here. So we just simply printed that and bonded it into the tool. So we combine technologies when needed. We have this analogy in 3D printing, often, fail fast. So we always make a joke, we've never failed, but we've learned a lot. So using that, we're always trying new ideas and better ways to design and develop tooling. So this shows a coating probably 4 years ago. Coating package we developed. This is probably a couple of years old. This is an Ultem tool. And again, very good printing, FDM technology, but it will delaminate. But it's very high temp. The TG on this is like 400 degrees F. So you can definitely pull some good parts. But what this does, when you fail often, fail fast, you can rotate that PDCA in the development process very quickly to test your designs. So this is one of our failures, and we've had a few, and that's how we learn. This is a FDM tool. There was one part formed off of this, HDPE 250 gauge, and you can see, that material sits on there for probably 2 minutes. So, it will melt the part. But if you were pulling ABS or things like that, you could pull some parts off here. There's a lot of different technologies to use. We've even had tools like, this is our tool here, we even had things like people hit it with the forklift and things like that. And forklifts are pretty strong. But they're very durable tools. This kind of shows where our tooling fits. So part quantity is here, so from 0, 10,000, whatever parts. Part size and complexity, so as the part gets bigger and more complex. Ren wood will never go away. It's a good option to make tooling. The metal tool, aluminum tools won't go away, higher volumes, or when you have to control the temperature. Our tooling, it's just a tool in a toolbox, but we feel it's a very powerful tool to fit in a lot of applications, but we'll never replace those. So the key benefits of 3D printing tooling are low cost and less waste because you're just printing what you want. There's less machining time, so the time is money, and we're able to produce thousands of parts. So the binder jet that I talk about, our printer is 70 inches by 39 by 27. We can print that in 18 hours. And historically, 3D printing is slow. And you've all seen it, it's very slow, but that's fairly fast for 3D printing. So we can either print a bunch of smaller tools in there or some large tools. So that's why we've kind of focused in on that technology. And this is kind of an example. So, maybe this is a pretty small tool, 34 by 36, but if you had like packaging, for example, we do a lot of that. And these are returnable dunnage containers. So these would all be different for like transmission or powertrain packaging. And if you wanted, 500 parts, maybe you do in this material, there's 6 different pallets. If you were to do traditional machining, and if you want them very quickly, you'd need a lot of machines. Of course, you can run 24/7. We would print all of these in 18 hours and then process it. So that's the, time is money, and you can't buy time. Although you can buy time up to 24 hours a day, and then there truly is no more time. But it gets expensive. And these are just some examples of tooling, some very large tools. You know, some of these you could imagine forming these things out of Ren. You know, they're very brittle. This is a demo tool, which I think, you know, if people are interested, they can try that demo tool. We can send that to you. These are 40 by 48 pallets, a lot of different things. So kind of showing the size of the tooling we can do. And more than thermoforming tooling, there's also trim tools. So this is one idea for trim tool. This is not a porous tool. So we have the O-rings around here, and we put holes in here to vacuum through a part, CNC trim it. Also this type with the vacuum cups. So different, you know, different designs, and of course relief here where you machine it in the holes here. So different options there. Check fixtures is sometimes important. You need that, so we can print those. This would all come at one time, one package, same technology. And then we also have got into quite a bit of this assembly tools. This is an ultrasonic welding fixture for like the carpet on the inner liner of a car, the carpet on the inner wheel well. So there's a lot of opportunities to apply this for tooling. So some considerations is the technology is always changing. So we always want to keep abreast of the newest technology. And this is an interesting fact. You know, tool makers are getting older. And you know, there's potential for limited CNC skill set. We all know that. So that's always a concern for everybody. Just even finding people to load plastic is a hard job. But this is you know, this is an issue everywhere. So 3D printing, you know, kind of alleviates some of that. Not all of it. You're still going to be CNC cutting some tools, but this is a pretty important fact. Also, 3D printed tools, it's only a tool in your toolbox. It's not going to solve all of your tooling needs. But when quick turnaround time's needed, that's when it really makes sense. Volumes, so our tools, we've done up to 5,000 parts. We can get much more out of that. This is production data from customers, so we know we can do those kind of volumes. It's continuously changing, so we're always keeping up to speed on newest technology. And kind of important for most people, it's a one-stop shop. You just don't want a printer. You want the complete tool. This is interesting. You know, for a 3D printed tool, there's a lot that goes into that, from engineering, tool design, 3D printing as part of the process, the coding package, you know, even customer service. But honestly, the easiest thing we do is 3D print. That technology has been around for years. This is where kind of our value add is, from the design side, our coding package, and how we put all that together as one-stop shop. 3D printing is, you know, very high-tech, that process, but that's probably the easiest thing we do. This is just an example of a tool. I think this is the ABS 125. But very simply, you know, we pull apart. The nice thing about this tool is we pull over 100% of the area. So we pull a better quality part, better material distribution. And then because it pulls quicker, you have less tendency for chill lines. You don't eliminate them, but there's less tendency because you're pulling much quicker on the part. So I don't have a lot here. More question and answer if you guys, we can talk about some of your questions, but that's kind of what we have. We're at booth 300. We got a lot of tools out there, videos and stuff. You can come take a look. Any questions? Sure.
Hey, so you mentioned coatings very, very briefly. Is that something you use on a thermoforming tool? Are you coating them, or is that more for the tech tool?
No, we use that on all of our prints. That's a proprietary resin that we developed, and it gives you the strength of the binder jet print. Binder jet's not very strong. It gives you the strength and then the thermal characteristics for thermoforming. That's kind of our secret sauce, is we develop that coating package and then we infiltrate the tools and process them.
Can I ask a follow-up?
Sure.
That coating, so, but it's still porous. Thank you. So the coating doesn't interfere with the porosity that you need to draw the part down.
Right, but it's still a fully porous tool
Neat.
because of the way we process the, yeah.
Any other questions? Oh,
Thanks. Yeah. First, your gauges, do you do all the scribe lines and everything on them?
Yeah, we print, everything's printed in, yeah.
It is?
Yep.
Okay.
And we print them maybe 300 micron resolution. So, you know, they're not like 25 micron if you were machining that kind of tolerance, but we'll do within 300 micron, 12 thousandths.
Okay.
Is,
And your trim fixtures, so let's say, you know, we normally like to locate off of the A side, and if our A side, or excuse me, tool side, and if our tool side is the A side of the part, do you have any issues with marring of the A side or anything like that?
not to date. I mean, that's a good point. Actually, it's a good point because it's still silica sand. It's still,
Right.
it could be potential for that. That's a good point.
Yeah.
Yeah.
So whoever hasn't used Catalysis yet, I was very skeptic on, we had a prototype solution using wood or Ren boards, and then our production solution. We never had anything in between. And I was always a favor of, you know, we're building billet or aluminum, water cooled, and our plants are going to benefit from that whenever they pull it off the shelf, right? We're never going to have an issue. And, but the customer doesn't always want to pay for that.
Yeah.
And so now we've got, I think, half a dozen or so tools.
Yeah.
And I would say very good success. Darrell offered us a trial tool. We learned a lot about cycle times, you know, how much heat maybe it would, you know, if it acted like a heat sink. And we learned a lot there, and then the tools we ran so far has been very good success, so
Yeah,
thank you.
thank you. Thanks.
Yeah.
Yeah, we offer a demo tool. It's out at our booth. It's about this big, and if anybody's interested, you know, I could talk here all day about it, but I want to get a tool in your hands. You put some HDP on there, try to burn it up. Just don't drop it from 10 feet, but, you know, try to break it, and then you guys can decide on your own.
I have a question. I was very surprised at the volume that you could print off of your, what I considered at the time that I first looked at this as more of a prototype tool, but obviously at 5,000 parts, that's a full-blown production tool under the right circumstances. When we originally talked, you said you thought it was lower, and it's obviously gone up. Do you see the number of parts that you can make off their tool increasing over time as your technology changes?
Yeah, good question. We you know, basically the tool is silica sand, which can handle thousands of degrees. Our coating is designed, the TG of the coating is over the 350 degrees F of thermoforming. So if you never go over that 350, you never change the chemical composition. On paper, it will never break or fail, but everything breaks, everything fails. But we have production data for 5,000. That was actually 187 ABS. We've got production data from customers, what's it, 1,200 HDPE 250 gauge on that. Actually, the one that's in the competition.
Okay.
That's 1,250 parts, so you can look at that tool. So, yeah, there's definitely a lot of room for higher volumes, but we don't have actual production data. But I know we can get a lot more.
Great, thank you. Any other questions?
Could you pick some arbitrary tool costs in both Ren shape and water cooled aluminum, and then kind of say where you could fall in that?
Yeah, it's a lot of case by case, but generally, our target is always half the cost of a metal tool, and we're about price even, I would say, with Ren. But it's always case by case, and it depends who you use. But that's if you go outside to get your tooling made outside, our tool versus a Ren, and then metal, either billet or cast. The problem with cast is it takes so long. Our target's always half the cost.
And then, and do you take from a solid model, or do you like to have the customer, you know, predict the shrinkages and give you an actual model to make?
Yeah, the only thing we need is a step file of the part itself, and then we just need to know your shrink, ABS, if it's 6,000ths or
Yeah.
HDP, and then we'll design the tool, but the base and the run and everything we design with you as a customer to get exactly what you want, so it fits up to your machine. Some people have different locators, how they trim their tools, but the base tool, because we do a lot of things on the back side for honeycomb type design for strength and thermal management, we have to design that, but the rest of it is kind of a joint effort, but we design it. Just get your approval.
Thank you, yeah.
Good afternoon. And we talk about thermal management on the tool, for example, between running ABS and, say, HDPE, there's a lot more thermal gain when you're running a polyethylene or polyolefin on there. Does your tool stabilize at any temperature, or what do you do about heat gain if you're running, say, a production run, every day, and you're running, 400 or 500 parts?
Yeah, good question. ABS, pretty simple. I mean, we've got testimonials on a shuttle at 187 ABS, or the heating time, whatever that is. They haven't changed the cycle time, same cycle time, and they do 500 a day on this ABS. HDPE is our customers, we don't know exactly how they're managing the thermal issues. Some of them are doing increased air blow because the tool is porous. So they do 10 or 15 seconds of air blow, it cools the tool down faster. They use fans, they use misters. We just understand, but we don't know everything they're doing to manage. But HDPE is a tough one. Semi-crystalline, it actually heats up. And if you're doing that in a rotary, there's a lot of thermal management things you need to think about. And even some of them even skip. They may do 3 or 4, skip a carrier and do it that way. But our tools aren't made for 5,000 parts necessarily. You might want a metal tool that's water cooled. 500 or 1,000 parts, you'd use our tool so you could afford that extra cycle time because the tool is half the cost. Does that answer your question?
Yep.
Any other questions?
Back in the day when we used to buy a lot of cast aluminum tools, for quoting purposes, we had a number that you would take the length, the widths times the height and got the volume, and then it was, I don't even remember the number, but it was $1.50 a cubic inch or $3 a cubic inch. Is there anything like that, just for a talking number, not for a promise, that you could use as a ballpark way to estimate?
Yeah, it's a hard question to answer, but I can tell you, a tool about this size is maybe $1,000. And then,
Is that 10 by 10 by 10, you think?
yeah, it's hard to, I would say 10 or 12, but about maybe 4 or 6 inches, it's probably about $1,000. But yeah, when you get into bigger tools, you need to look at the costs.
They quoted a 9 by 9 by 9 the other day, around $900, if that gets you pretty close.
Yeah, part of it is that we have so much design on any tool. If it's this big or this big, the base is so much, and the coating is so much money, so.
Anybody else?
Sorry, I just realized I might be between you guys and a cocktail, so sorry about that. But I have a tool, we got a tool from them, and it's so far so good, we're just testing it now, but, so I can certainly say the technology for us is, it looks like it's going to be great. But one question for you is, Darrell, is, next technology, so you're always looking at new technologies, and, this one works well for you now. Is there one on the horizon that you see that has even more benefits?
Yeah, I think, honestly, binder jet metal, there's metal 3D printing, DMLS, and things like that. The machine, it only prints 10 by 10 by 10. It's about $1 million. They have binder jet metal powder, and they'll print about 24 by 24, and they're about $500,000. So the cost is coming down, the size is getting bigger. When we can do metal tools with conformal cooling and direct print, no post-processing, that's what I think will be in another 5 or 10 years. Right now, metal is really cool. We've got some little metal tools out there, but it's really expensive right now.
Do you think that really competes at that point with aluminum tools?
Yeah, then when you can direct print, maybe in days, conformal cooling, wherever you want. Now you can do some unique things with traditional tooling, but I think when that cost comes down and the resolution is high enough, it'll start to make sense. But it's 5 or 10 years off, I think, at least.
Hi. I was wondering, so you said your tools are binder jetted?
Yeah, the base print technology, what's
So
called binder jet.
What material is that then? Because my understanding is that binder jetting was primarily powdered metal.
No, that's one form of it. Binder jetting is also silica sand
Oh, okay.
and different types of, there's other kinds of sand. It's just 150 micron sand, not the same stuff at the beach, but looks kind of like that. And then there's a Furan binder glue that you put that down each layer where you want the part to be bound together and UV cured, cross-link it.
And I had another question. What CAD software do you use? SolidWorks?
Yeah, we use SolidWorks.
Okay.
Yeah.
Darrell, how fast can you make me a tool?
Well, okay. Sekisui's here. We made some parts for them. We made 6 tools, and you're not allowed to ask that question, in 2 days for first show you had. And so we can very quickly, that's expedited, of course. So printing 18 hours, I think we were driving up when the printing was finished, picked them up, processed them, and yeah. Don't expect everything that fast.
Have you ever tried cooling the tools? Just post water lines in?
We do, we also use that same technology to make foam seating for automotive and airplanes. And we actually put copper tubing on the back side of it because they want to maintain 150 F plus or minus like 10 degrees. So we put that on the back side and ran water through it. But silica sand's not super conductive. But it did help. But there's a lot of cost involved with all that. If you don't need it and you keep the tool porous, if that fits your needs, it's much easier and lower cost to do that.
Is there a way to make repairs on the tool? Should it get damaged? Can you
Good
talk about
question,
that?
yeah. Very similar to like a Ren or metal tool. If you wanted to, say you had an area and you wanted a different profile, you would machine that area out to CNC. We'd print you a new piece, bond it in, and then you'd have the new profile. We've also taken a tool that it was additive, so they wanted the features to be added. You didn't have to machine it. We printed that piece, put it on there, finished the tool, and then we modified it that way. So you can add to an additive or subtract from an additive. But if you have a tool that's maybe this big and you want to modify this area and it's substantial, the cost to set that up on a CNC, machine it, we print a new part, you bond it in, it's faster and lower cost a lot of times to reprint the tool.
How about on the customer's site?
Well, heck, yeah.
Yeah, I'll do it.
You can answer that one there, yeah.
Yeah, I've been to the customer site. How come fix your tool?
Yeah, we have
Let me clarify. For a thermoformer who has an in-house tool shop.
Yep. We've had a customer, honestly, I was amazed at how much modifying. Good, big tools, they were like probably 8 inches long by 40 inches. It was like a wheel well, and they modified the whole top of it, machined it off, and then they actually did a Ren piece and bonded it on. So we were going to print that piece, but they had an in-house tool shop. And I'm amazed at how people have modified. We don't always see everything they do, but they'll machine it out, they'll put Ren in, sometimes we'll print a piece and they'll put it in. So it's very modifiable, I guess.
Okay, thank you.
Let's say if there was a blemish, a tool got dropped on it or something
Yep.
small.
Yeah, so are you guys familiar with like a P17 high temp, like a body Bondo type thing? It's used in thermoforming a lot. We use that a lot, and so do our customers. If there was an area that was chipped or something like that, and they'll hand finish that.
I have a question in regards to graphite. Graphite is a good conductor. Is there any movement looking at 3D printing graphite and using as potentially for the thermal issues in the future?
Yeah, good question. We haven't done anything with it. It's like technology is always changing, and I don't know why you couldn't add that to the silica sand. We've never tried anything with it.
I know it's expensive, but
Yeah.
I think it's one of those areas
That's a good
that
point.
further
Yeah.
down the road, there may be some opportunities for that.
Good point, yeah. Especially if we're going to do some conformal cooling, that would make it more conductive, and then we could take advantage of the cooling. Yeah, that's a good point.
Any other questions?
Sorry, you were talking about the low thermal conductivity of it, and that's kind of being an impediment to putting cooling channels in, but is there anything stopping you from just putting really tiny cooling channels in all over the place? I mean, do they have to be so far apart?
Well, the tool is fully porous, so in essence, it's a lot of teeny little channels in it. And why we can't do conformal cooling in the binder jet, because it's porous, so we could
Right.
print it in there, we could do some really cool things. How do you seal that? You know, as braze, maybe we could put some coating in there. But, yeah, it's in development, and we haven't done anything with that.
Thanks.
Good questions, thank you. Any further questions? Well, I don't want to stop the bar from, they'll be sending the bartender down here soon. So thank you so much, a great turnout. And Darrell, thank you. It was a great
Thanks, Ian.
presentation. And let's continue to look at new things that can make thermoforming stronger against the composites and the injection molders. Let's make that pie bigger. Thank you.
Thanks.